Alright, so in this problem, I have x to the power of 9 plus x to the power of 6 is equal to 36. So I want to find the value of x here. Now, x to the power of 9, I can rewrite as x to the power of 3 times 3. And x to the power of 6, I can rewrite as x to the power of 3 times 2. So I get x to the power of 3 times 3 plus x to the power of 3 times 2 is equal to 36. Now from here, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 3 times 3, that's equal to x to the power of 3 to the power of 3, and x to the power of 3 times 2, that's equal to x to the power of 3 to the power of 2. And this is equal to 36. Now I'm going to let x to the power of 3 equal to the variable t. So I get t to the power of 3 plus t squared is equal to 36. And now if I subtract 36 on both sides, I get t to the power of 3 plus t squared minus 36 is equal to 0. Now to solve an equation like this, what we have to do is first find one solution and use that solution to find the remaining solutions. And to find that one solution, we just actually have to plug in numbers and see if they work. So I'll first start with t is equal to 1. If t equals 1, I get 1 to the power of 3 plus 1 squared minus 36, which does not equal 0. If t equals 2, I get 2 to the power of 3, which is 8, plus 2 squared, which is 4, minus 36, which again does not equal 0. Now if t equals 3, I get 3 to the power of 3, plus 3 squared, minus 36, which does equal 0. So t equals 3 is a solution to the equation. Now what we can do with t equals 3 is divide t to the power of 3 plus t squared minus 36 over t minus 3. And whatever equation we get from this is what we have to factor out and find the solution to. So how do we divide these two? Well, t to the power of 3 plus t squared minus 36, I can rewrite this as t to the power of 3 minus 3t squared plus 4t squared minus 36. And from here, I can factor out t squared from t to the power of 3 minus 3t squared, and 4 from 4t squared minus 36. So I get t squared times t minus 3 plus 4 times t squared minus 36. And t squared minus 36 is the same thing as t plus 6 times t minus 6. Sorry, this isn't supposed to be 36, this is supposed to be 9. So I get t plus 3 times t minus 3 is equal to 0. Now from this whole thing, I can factor out t minus 3. So I get t minus 3 times t squared plus 4 times t plus 3, which is equal to t minus 3 times t squared plus 4t plus 12, meaning t to the power of 3 plus t squared minus 36 divided by t minus 3 is right here, t squared plus 4t plus 12. So now this gives me two equations. I get t minus 3 is equal to 0, and t squared plus 4t plus 12 is equal to 0. So obviously t minus 3, we already know the answer to that is t equals 3. But for t squared plus 4t plus 12 is equal to 0, to solve this, we're going to have to use the quadratic formula. So I get negative 4 plus or minus the square root of b squared, so 4 squared, which is 16, minus 4 times a, which is 1, times c, which is 12, all over 2a, so 2 times 1. And this is equal to negative 4 plus or minus the square root of 16 minus 48 over 2, which is equal to negative 4 plus or minus the square root of negative 32 over 2. And this is equal to negative 4 plus or minus the square root of 32 times the square root of negative 1 over 2. And the square root of 32 is the same thing as the square root of 16 times 2, which is the same thing as the square root of 16 times the square root of 2, which is the same thing as 4 root 2. So this is equal to negative 4 plus or minus 4 root 2, and the square root of negative 1 is the same thing as I. And I have this over 2, and now if I divide this by 2, I get negative 2 plus or minus 2 root 2I. So t is equal to negative 2 plus or minus 2 root 2I, as well as 3. Now, we're not done yet, because remember how we let x to the power of 3 equal to t. So I get x to the power of 3 is equal to 3, and x to the power of 3 is equal to this. However, we can't take the power of a number and make it have an imaginary solution, so we cannot use this solution of t. So the only solution we can use, x to the power of 3 equals 3, and if I take the cube root on both sides, I get x is equal to the cube root of 3. Alright, so in this problem, I have 2 to the power of x minus 3 to the power of y is equal to 7. So I want to find the values of x and y. So for my solution, if I have something in the form 2 to the power of x minus 3 to the power of y is equal to 7, I'm going to rewrite 7 as 4 plus 3. So now I have 2 to the power of x minus 3 to the power of y is equal to 4 plus 3. And the reason I did this was because 4 is the same thing as 2 squared. So now I get 2 squared plus 3. And notice how I have something in the form 2 to the power of number minus 3 to the power of number is equal to 2 to the power of number, and I also have 3 to the power of 1. Now from here, I'm going to group the powers of 2 together and group the powers of 3 together. So I'm going to subtract 2 squared on both sides. So I get 2 to the power of x minus 2 squared minus 3 to the power of y is equal to 3. And then I'm going to add 3 to the power of y on both sides. So then these two cancel out, and I get 2 to the power of x minus 2 squared is equal to 3 to the power of y plus 3. Now, for my left-hand side, I'm going to factor out 2 squared. So, actually, instead, I should say I'm going to divide by 2 squared. So, 2 to the power of x divided by 2 squared is equal to, well, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So that's the same thing as 2 to the power of x minus 2, and then I have this minus 2 squared divided by 2 squared is 1. And now this is equal to, from on this side, I'm going to divide by 3. So I have 3 times 3 to the power of y divided by 3. 3 is the same thing as 3 to the power of 1, so I get 3 to the power of y minus 1. And then 3 divided by 3 is equal to 1, so I get plus 1. Now from here, if I have something in the form a to the power of m times a to the power of n. This is equal to a to the power of m plus n. So 2 squared times 2 to the power of x minus 2, this is equal to 2 to the power of 2 plus x minus 2, and these 2 and 2 and negative 2 cancel out, so I just get 2 to the power of x. So 2 squared times 2 to the power of x minus 2 is 2 to the power of x, and I have 2 squared times negative 1, which is negative 2 squared, and this is equal to 3 to the power of y plus 3. So I'm just checking if we distributed it, or sorry, if we factored out right, and it looks like we did. So now going back here, let me rewrite this. I have 2 squared times 2 to the power of x minus 2 minus 1 is equal to 3 times 1 plus 3 to the power of y minus 1. And notice how 2 squared, that's equal to 4, is an even number, and 2 to the power of x minus 2, well, 2 to the power of any number is even, and an even number minus 1 is going to be odd. So we have an even number times an odd number is equal to 3 is an odd number, times 3 to the power of any number is an odd number, plus an odd number plus 1 is an even number. So you have an even number times an odd number is equal to an odd number times an even number. Now, what I'm going to do is I'm going to set the odd numbers equal to each other, and then the even numbers equal to each other. So this gives me two equations. I get 2 squared is equal to 1 plus 3 to the power of y minus 1. And I also have 2 to the power of x minus 2 minus 1 is equal to 3. So let's first start with this equation. This is going to equal 4 is equal to 1 plus 3 to the power of y minus 1. And this means that 3 is equal to 3 to the power of y minus 1, meaning y is equal to 2. So the value of y is 2. Now for 2 to the power of x minus 2 minus 1 equals 3, I'm going to first start by adding 1 on both sides. So I get 2 to the power of x minus 2 is equal to 4. And now 4 is the same thing as 2 squared, so I get 2 to the power of x minus 2 is equal to 2 squared. And this means that x minus 2 is equal to 2. And if I add 2 on both sides, these two cancel out, and I get x is equal to 2 plus 2, which is 4. So my solution is x equals 4, and y is equal to 2.